Hello again, folks. It is great to see you all here. And please post your questions to chat. I will check them all in the end of the session. Today, we are talking about IntelliJ IDEA performance, how it improved in previous years, especially last year, what we did, why, and how. And also, I will tell you more of our plans and what we're going to do next. I will try to tell you some stories about how some performance improvements happened and what we actually did to overcome some performance issues. And first thing I would like to cover and tell you more about how we actually estimate and try to measure problems and their impact on your life, and what we do to understand the real impact on users and what we have in our arsenal to cover common problems. First of all, if we go to IntelliJ IDEA itself, let me open it, for instance, for a second. Here we have IntelliJ IDEA. It is a JVM application. It is running on top of Java, namely JetBrains runtime, which is a build of OpenJDK. And it is still Java application in 2024. It runs on Java. So we also use Java for IntelliJ IDEA development, not only develop features for Java, but also using Java and JVM languages on a daily basis. And in this application, we actually have a pretty big number of metrics and measurements that we collect in order to measure performance and impact on your life. If we, for instance, open logs folder here, we can quickly find interesting files here on indexing diagnostics, logs, OpenTelemetry metrics, and so on. And we also ask you, dear users, to help us with measurements and statistics and usage data. So if you see a notification inside IDEA which suggests you to share some usage data with us, you should know we do this. We ask you for feedbacks and usage data in order to improve performance in the first place. And this data usually helps us a lot to find, identify, and fix real performance issues. So most of the real-life problems, such as freezes, lags, or some exceptions, are reported by you, our dear users, who accepted such notification and functionality and who help us with your usage data. So like many users actually share usage data with us. We do not do this automatically. So if you would like to help us, you can share your usage data and help us with that. Now let's go back to the metrics and how we actually use them, how we use this usage data in order to measure some performance problems. One of the common metrics that we use, obviously, for many processes such as highlighting, indexing, completion, and logs, and many other parameters, is Apdex. It is a commonly used approach called Application Performance Index, and it indicates some kind of performance status. It reflects user satisfaction with the duration of application processes. For instance, if we talk about completion, we could estimate this Apdex index for the first item shown in completion pop-up, or maybe for the entire pop-up loaded, or even maybe for the time which takes to choose some item in completion pop-up. And Apdex operates on expert-defined ranges. So we should define some kind of the best possible time, which is excellent for completion pop-up, for instance. And then we try to derive other ranges such as excellent, good, fair, poor, and unacceptable from this best possible time and estimate that. And on the right, you can see example of such Abdex metric changed all the time for different languages. In the past, it was like 2 years ago or even more already, for different languages. For instance, for Python, we had perfect, excellent completion Abdex. And for Kotlin, we had some, worse experience that we would like to fix and improve in the future. And Abdex actually shows like exactly this. We operate with expert-defined ranges, and we have these categories. And what is important here is that we like collect a lot of metrics for many users, for many completion events here, and then we try to understand how they all fit into this. But it is only for the approach where we define ranges, like from our expert knowledge or from our observations, maybe from feedbacks or from other stuff. There's more like important approach that we use that was introduced by our data analytics team called MegaApdex. And MegaApdex is something that we like use to estimate how we usually improve the real situation for real life users, because ranges and like these events are based not on our expert like data or our expert opinion. It is based on real life metrics and on real life data related to users who leave our products or still use it. So it is proven by usage data, and this is why we actually ask you to share such performance data with us, because based on this, we can estimate the real impact of improvements, of performance improvements on your life. And here's the basic schema on the slide. How do we estimate some data? We get some logs from you, then we try to use specific optimization methods of which our data analytics team use to like have these groups of users and events. And then we try to use this formula to infer exactly one number between 0 and 1, which shows exactly the status of some feature and its performance on real life scenarios and users. This is how we actually can like see if our improvements convert into real life changes that are visible to users, and that like you will see in your IDEs and improve your life in the end. Okay. Now let's proceed to how it looks for us in the end of the day. We see here, for instance, MegaApdex for startup of IntelliJ IDEA Ultimate for various versions from 2021.1 and to 2023.2. You see, like we improved a lot from the 0.85 and up to 0.94, which is almost excellent as our users see it in the last summer version. And that's how we actually know that our improvements like really converts into visible improvements for our users, that this ranges and lines, they go up all the time. I would like to say a huge thank you to our data analytics team, and especially to data analytics working on performance for us, because without their effort and without their input and work on MegaApdexes and ranges, we would not be able to see our impact on your life and your daily routine in real life scenarios. So thank you, folks, for working with us. Okay, next topic is what do we do to understand what goes wrong. For instance, if you come to us, to our issue tracker, and say like, hey, folks, I have a performance problem here. There are tons of freezes, or there are some performance issues, or there are, I don't know, some slowness in the editor, and so on. We now use OpenTelemetry as a standard API for performance metrics that we like really log a lot of performance metrics in this format and push those to logs folder. So if we open once again this logs folder, you can see CSV files, like regular CSV files. You can even open them. There are a lot of different numbers with lots of strange names in there. Those are numbers from IDEA function. And there is also HTML file which can be used to visualize such reports. You can use it also to see what we actually log, such as JVM memory or CPU usage, or maybe a virtual file system synchronization, and so on. And nowadays, OpenTelemetry is a commonly used format for such detailed metrics that we collect. And this is how you can actually help us with investigations and with performance problems. You could just archive this folder with all this stuff and attach to the issue, so we can understand the context and the problem better in issues. OpenTelemetry is great, quite a nice library and API which we use, and also quite important that we can visualize results in many ways. Okay. Now I would like to proceed to stories, because I promised stories to you. Let me tell you some and tell you how IDE evolves and solves crucial performance problem in your daily scenarios. And we start with startup for sure, because first of all, in order to use our product, users have to start it somehow. And let's see. I have IDE up and running here. Let me clarify a bit about IDE and what we use nowadays. As I mentioned, IntelliJ IDEA is a JVM application. It runs on Java. It still uses Java Swing for UI, so you can spot that we actually customize it a lot, and we have new UI nowadays. But still, it is not based on any other UI library. It is still well-known Java Swing, but with many improvements in look and feel, and many improvements in JVM itself. We have a team, JetBrains IntelliJ team, folks who work on Java internals and patches for many Java subsystems that are required for our UI and for our work on different platforms. That is why we can also use more modern mechanisms such as metals on macOS or Wayland or Linux on Linux, for instance, because we also invest heavily into JVM development and try to apply recent latest patches, and also collaborate with many folks on OpenJDK to fix issues that we have on IDE. And when you start your application, let's back to startup, we actually have to start JVM itself as a binary, as a native application, which will load all our subsystems, a lot of jars, then locate class files there, then instantiate all the plugins and start loading. So for instance, if we restart our app, let's see how it looks like nowadays. Okay. Oh, I have a debug version. And let's see how it looks for you. I have a fresh version out of EAP program, so you can also check our early access program for IDEs. Okay, where we're heading. Oh, we started much faster, and you see that we actually opened IDE and show you code right away, and you do not see any indexing, and we also loaded all the line markers right away, and many things changed recently. But last year we had a lot of problems with startup, which we tried to solve. And now I will tell you which ones and how we tried to solve them. The most like the oldest problem for us would be dependency injection and application components. Many years ago, IntelliJ IDEA used a special dependency injection mechanism called components, such as project component or application component. And we also supported dependency injection via constructor injection in components. So you could define a Java class, then mention this Java class in a special descriptor of a plugin or of IDE itself. And this component would be instantiated at startup when IDE loading. And what does it mean actually for us? Is that in order to even start IDE, we had to instantiate all of those application components from all plugins, which is kind of evil. We have to load all the classes and we have to create them. We have to load all their dependencies, like classes they depend on. And also we have to use right order for constructor injection. And this led to huge problems with startup. And because of this, we cannot easily start and optimize hot paths. Nowadays, it all gone. Last year, we got rid of all the application components in our code base, and we now always avoid that. And instead of dependency injection and constructor injection, we use a simple pattern called service locator instead. On the right, you can see such service defined in our code base, for instance. It is a simple class which receives a project in the constructor and annotated with annotation service. And in order to use that in code, we ask a project for this service by class, like service, like project, get service, and my project service. And what does it mean? Is that we can instantiate such services lazily on demand and not on startup anymore. And this is how we actually now build our IDE and plugins in all the places. We no longer have central dependency injection mechanism, but instead we always ask for services when they are needed, actually, when we try to use them. And that's how we actually improved startup a lot, because there are no longer inefficient dependency management. And we can easily optimize hot paths and use lazy loading here. Here, I also would like to mention our change of our startup to parallel. Before, like last year or maybe a year before, we used to have a special interface for plugins to start some activities on the project opening. And such interface was, first of all, blocking, like it was a call which have to do all the work and then get back to the platform. And also the process was sequential. We have to ask all the plugins for such class, call them one by one, and only after that we could proceed to some project opening inside IDE. And this was changed dramatically last year. We rewritten all the startup activities and startup code of plugins to asynchronous, parallel, like concurrent API, which is based on Kotlin Coroutines. If you do not know about Kotlin and Coroutines, you can learn more on kotlinlang.org. It is a special way of doing concurrency on JVM, which is like heavily based on idea of continuation and some asynchronous computations that run not on threads exactly, but on some special abstraction, and which use suspend functions as a base primitive, a special kind of functions that can be suspended, that can be waiting for something without holding thread they're running on. I will not dive into details on coroutines today because it is much broader topic, but mention to you that we rewritten all the plugins, and now our startup process is heavily parallel, packed a lot, and all the plugins they start their code in a concurrent manner, and we have such suspend modifiers for functions that run in startup process, which improved startup process a lot. And the final point for startup activities is class loading. We have a lot of plugins out of the box and also a lot of third-party plugins, and we know that they bring a lot of code, and they have a lot of extension points and a lot of actions, panels, inspections, and so on. And this cost us real time during startup, because in order just to execute the code, we have to load 50,000 class files from jars, from disk actually, which is not fast. And because of the reasons I mentioned, because of the parallelization and because of the improvements in this area, we also now can load those classes finally in parallel, which improves the situation because we no longer do this in blocking manner. And also coroutines allowed us to do this not on event dispatch thread, but we get back to it soon. I will tell you more of swing, event dispatch thread, and logs in there. So we also improved the situation with loading classes on JVM a lot, and we have a special charts and the special metrics in this area. Let me show you maybe some data for here. Here I will try to show you some real tool that we use in IntelliJ IDEA team called IJ It is basically a dashboard of all the performance metrics for our performance tests. We have them a lot. We have a lot of tests nowadays. And here we can see many metrics, such as, for instance, loading classes, like how many classes do we load. And also we can spot some degradations, and we can also analyze some specific types of classes, such as lambdas or inlines, or maybe method handle classes, and so on. And this is usually how we spot some degradations. We detect them automatically, put a red thing here, and we can analyze that then. Yeah, we also use a special kind of profiling for it. Let's get back to the slides. We use Yurkit to profile class loading. Yurkit is great. It shows not only loaded classes, but also stack traces and places where they are loaded. Indexing. I already mentioned in the beginning of session that indexing is kind of the most mentioned common problem that people mention for our products. Let me tell you more of how we improved this in recent, previous year, last year. First of all, thanks to many people working on indexing team and also in product teams, we improved multi-threaded indexing a lot. Like 25% improvement was achieved last summer, and we now are no longer waiting for logs, our internal logs, during parallel scanning and parallel indexing. Here in the picture, you can see many small red dashes. It is an illustration actually for the indexing process where many scanning threads interrupted and waiting for some internal logs that we had. This problem now is gone, fix it and improve it, and we observe a huge 25% improvement on our huge monorepo, where we code IntelliJ IDEA itself and have code for all the JetBrains IDE products. Not only that, we also changed a bit how we deal with various build systems. I know maybe some changes may sound strange, and also not everyone likes them, but we disabled downloading of source code for Gradle sync, the same as was like done for Maven for many years. Maven users do not struggle about that, and they download sources for libraries on demand. But for many years, for Gradle, we had to download sources of libraries always and could not do this on demand. Last like previous release 2023.3, we disabled automatic downloading of sources for those libraries. So in case you search and navigate to such library classes, you'll see such blue panel where you will be able to do this, basically the same as it was for Maven. And this change actually improves not only like the loading part of sources, yeah, it also greatly improves time for indexing of sources. For instance, on Spring Boot project, I mean Spring Boot project itself, a huge project available on GitHub, this led to improvement of 50% faster indexing on Spring Boot project. So you should not wait for indexing of those. It doesn't affect like searching for classes, methods, and many other usage searches. It may be sometimes it could be inconvenient in different scenarios, but we are improving usability and UI in this area to make it more like easier for you to attach such libraries one by one, and do not wait for indexing of all of them, because indexing not only means like spending time on indexing itself, it also means that indexes, which are files on disk, would be bigger. It would be slower to search through them for many things you would like to do in IDE, such as usage search or completion, or maybe some quick documentation stuff. So it also improves the situation for many other applications. Okay. And finally, this release, we focused on actions which are available while IDE indexes things. We improved search for classes and symbols. We improved completion. We enabled run actions during indexing. And now if we go and compare different versions of IDE before and the release we are preparing for you now, you would see difference clearly. So it is the same like state of IDE. IDE is still indexing code, like it does some scanning and indexing. But before you saw this, like not ready and seem not highlighted even, and now you'll see this. You'll see that everything is highlighted and seems ready, and also we are improving running experience, so you would be able to run tests and applications without waiting for indexes to complete. And not only that, last year we improved scanning and indexing processes. So we no longer start indexing, and we no longer show any progresses because of that if you change nothing basically in the previous session. So in case you just restarted IDE, or you go to work in the morning, start your IDE and open project from the yesterday like place, we will no longer show you scanning progress, because it is not important, and we can do this synchronously finally, and we will not disturb you, and IDE will be ready right away. Like you will be able to see all the functionality, use that, go to classes, run them, completion will work, many things will be available right away. If ID configuration has not changed and plugins has not changed, and you basically have the same IDE as yesterday. I think it is one of the biggest improvements in the perception of our products. And please try our AP version and let us know how do you feel now, and what you can now do, and do not wait for indexing to complete. Okay. Completion. In this area, I would say that many improvements were achieved because of traditional profiling fixes and improvements, but one improvement, namely in Kotlin, certainly stands out. I would like to say a huge thank you to our machine learning team, who employed machine learning methods to improve completion, actually, not teaching some AI stuff, not teaching some ML to provide some answers in chat, but employing ML techniques to reorder some completion code, prioritizing most relevant contributors in completion, which resulted in improved not only Abdex scores, but also improved MegaApdex score on real-life user scenarios. And we see how it improved from poor to good enough. And you could also spot the difference before even changing any logic. So the entire change was to prioritize completion contributors, which find and show you some completion items based on a specific machine learning model, which can do this correctly and improve and prioritize more faster, more relevant contributors on some less relevant, less performant ones. Yeah, so you could also spot this. We released this last December. Okay, what else? Highlighting, obviously, because many people struggle a lot because of the slow highlighting in the editor, and they complain a lot that it is slow while I'm waiting for it, and what does it take to highlight this Java file? Well, let me tell you some stories about highlighting. We also fixed a lot of problems in there, but some are certainly interesting. First of all, we introduced cached editor markup, subsystem, which caches all the highlighting and line marker, for instance, on disk. So when you start your IDE again, they would be shown immediately, and you would not wait for it. On the picture, you see analyzing is still shown, that we not even started to run any highlighting here, but we already see line markers highlighting here, all the annotations highlighted, and so on. So you can easily spot this in IDE, like when we just reopen files, we no longer see any delay in highlighting. It is also based on this. We show you all the cached data if file has not changed from the previous session. And we start a new highlighting session asynchronously in order to update line markers, inspections, some maybe colors, and so on. So you could see this improvement also in 2023.3. Great improvement thanks to our IntelliJ platform team. What else? Let me tell you a story about one of huge problems about IntelliJ IDEA and code. Also, a couple of years ago, maybe slightly less, we spotted such problem. On the right, you see part of the code highlighted, and part is not yet, and even black, and nothing seems working, and highlighting is stuck. What went wrong? Here, many problems were found. First of all, we realized that Java highlighting, in order to highlight something, in order to highlight annotation or references here, visits all the references inside Java elements. And here, by coincidence, inside query attribute, there are references to Hibernate, to HQL query, parts, entities, attributes, and so on. And in this example, Java highlighting, we're trying to find and visit and resolve and find source, of such Hibernate GPQL attributes, which led to such frozen highlighting, because finding source for Hibernate attribute, for instance, is not a cheap process. You have to build JPA model, understand which entities do we have, which attributes used. You have to find some Hibernate mappings and entity classes and so on. And we realized that this problem actually caused by quite the old problem that back then in 2015, for instance, there was a language which can be mixed with Java and which used Java constructs inside the internal strings, inside the parts of strings, and it is called Google Web Toolkit. Maybe you heard of it, maybe you remember of it. It is kind of Java for web, which enabled you to build Java apps for web browser, compile Java to JavaScript, and so on. And in order to fix some issues with find usages and maybe highlighting there, we introduced such correct measure that would visit expressions and code inside Java string literals and try to find their source. And it is actually causes a lot of troubles and problems for regular Java development, such as GPQL, for instance, or SQL or something else. So the straightforward fix would be to limit such logic only for Google Web Toolkit language, and do not try to do this for regular Java code, and it is not needed there. There are many more problems found during this investigation, but they are less interesting, I guess, and we can omit them for today. And this is it was a huge, I would say, performance penalty. I show you this screenshot. It is a screenshot from a real-life project of Red Hat company called Kicklock. You can easily locate this code in their GitHub repository. We actually really like this project because it shows all the real-life problems, all the real-life struggles and performance problems, especially because it is quite a big real-life product/project that we can easily use as a target for performance improvements. So thanks to the authors of it. The next problem probably exists for many, many years. It is about JSON files, YAML files, and files that connected to some JSON schema. You probably know of JSON schema. It is a special standard for JSON configuration, which enables you to have some validation capabilities, some completion, highlighting, and other stuff in editor based on a specific special definition of document called JSON schema. And we had a specific issue with one of JSON schemas attached to JSON files, namely Azure Pipelines schema. It is quite a big, quite a huge, I would say, schema with many, many, many other attached. Let me show you attached schemas. So if we try to open it, we can easily find it is not only big, but also uses a lot of references to other documents. And finally, if we would try to combine one JSON schema for this one JSON file, I would say, for such JSON schema, it is quite huge. And the problem was for us is that back then, before any improvements, we used our own lexer and parser and PSI structure to load such files. And what I should mention here is that IDE, lexer, parser capabilities, and so on in IDE optimized for editing experience, not for parsing performance, not for some kind of batch processing or some batch improvements. We optimize our parsers for incremental updates, for some navigation, indexing, and many other things. And what it does to the JSON and this issue is that it is pretty not optimal, I would say, to parse such huge JSON documents with our own lexer and parser capabilities in IntelliJ IDEA. And because of this, when users tried to use this Azure pipeline schema, they had quite a huge memory allocation in their IDE, like 20 gigabytes of memory traffic, only to open a file, maybe a small one file, which uses such JSON schema, which is a huge problem, not only because of the slowness of the process, but also because of the garbage collection, which is like caused by such huge amount of garbage generated in the process. And finally, I would highlight here that we finally fixed the problem. We switched to JSON parser in this like area. It improved the process of highlighting and completion a lot. For instance, on this test, on a real end-to-end test, which opens a file using this Azure pipeline schema and highlighting it and calling completion capability in there, we like observe change in inspections run from 18 seconds down to 1.5, which is huge improvement. If you struggled before with some JSON documents or YAML documents, I would encourage you to try our AP version and see if it improves your life actually. I would expect that, yeah, it improves. Freezes and lags, maybe the last thing where we have many improvements recently. Let me tell you more about what do we have under the hood. IntelliJ IDEA still uses Swing, as I mentioned. And one of the implications here is that it uses a single event loop, single event dispatch thread. Here's the illustration. And we also use a special lock, special read-write lock implementation, which allows us to have one writing thread which changes the world, I would say, in our meaning, and also many read threads which can run in parallel if there are no pending writes or parallel writes. So write is kind of exclusive operation which runs without any parallel activities, and reads can be parallel if there are no writes. And also we have a special kind of read which performs read and does not allow writes to start, which is useful in some specific cases. And because of this, we have a huge problem with freezes and a huge problem with flags because of the old, quite outdated code, which does some heavy computations, heavy like changes on this event dispatch thread and causing the issues with responsiveness of ID. So what we improved here, let me highlight that. Last summer, we implemented, or maybe fall, we implemented faster, stronger, better update of actions menus and context menus based also on coroutines. So now you can easily see that opening context menu is no longer a pain. It is actually fast, like immediate, without any progresses shown. You do not see any spinners and waiting for it. And also main menu is fast as hell, because we now are able to run update for actions in parallel and also compute if they are enabled or not in parallel using coroutines. And this process is like heavily concurrent and enables us to employ all the cores of your machine to show you menu much faster and do not wait for it. So if you could easily spot the difference if you open the IDE a year ago and an IDE now, you can easily see how much faster menus became. What else? You could probably face this problem before if you do a lot of changes outside of IDE, for instance, git pull or maybe build or maybe something else, some huge change not inside the IDE window, and then switch to IDE, you could face such file system synchronization dialog, which is blocking, which is not, it doesn't allow you to use IDE before it processes all the files. And it is also because of this, because IntelliJ IDEA uses single read-write lock, and it have to maintain some guarantees of consistency, and it have to use a special virtual file system under the hood. And we now try to fix those. We first of all improve the situation with workspace model and improve like synchronization process itself, so it is much faster, and we no longer do a lot of checks, synchronous checks under the hood. And we also implemented prefetch, which does this even before you focused ID. Oh, sorry, blow up. And now you can expect that once you change something on disk, IDE spots this change immediately and tries to like sync those files without even waiting for you to switch to IDE, which improves the situation, and you probably should not face this modal state anymore. I would like to also highlight briefly importing project improvements. They are important and huge. First of all, Gradle project import improved a lot. We introduced many improvements there, and we no longer put ID to dump mode and while waiting for sync. We also improved parallelization in there, and we work closely with Gradle team, like from Gradle Inc., to improve parallelization further. Previous year, you could also spot many improvements in Maven imports. Like it is also now heavily parallel. We optimized generation of sources and memory consumption in there. We also posted such a nice picture on Twitter where we checked Maven import for a very well-known Quarkus project itself. You can easily find sources on GitHub also. And where there we had a huge improvement from 61 seconds to 30 seconds for the entire Maven sync for the entire Quarkus project, which is quite big and have hundreds of modules, which is quite enormous amount. And if we also check our MegaApdex metrics, we see that we really changed this for our users, and it is much better perceived now. And not only this is in tests, like observed in tests, but also users can easily spot this on their own real-life scenarios. Here, finally, I would like to mention ongoing work on K2 compiler in Kotlin. Please stay tuned. There are many more changes in Kotlin this year. Our team and the team of Kotlin compiler work closely on introducing K2 compiler, which is much faster, much more parallel and concurrent, and this would improve situation and perceived performance and real performance in IDE further. For instance, if we check our dashboard for Kotlin K2, we can easily spot that in like most of cases, completion improved for up to 4 times sometimes. Like it was 4 seconds before, and now it is like 1 second or something like this. In many scenarios, Kotlin K2 shows much better like performance on highlighting, completion, find usages, and many other tasks. I would maybe skip the question on JBR 21 this time because we have somewhat limited time. But because of our tests and performance improvements, we can now easily spot any performance degradations. And such degradation was caught recently when we tried to use fresh Java 21. We faced with a big degradation in startup time. And because of this, we postponed such activity, migration to new Java, but we continue it further in this summer release, and we were able to fix this. And this is, again, a huge thank you to our test automation team, who does great job on maintaining our performance tests and observing any degradations. I would also mention some tools that we use. We heavily use our own profiler based on async profiler named IntelliJ Profiler for CPU, memory allocations, and heap dumps. Sometimes we use YourKit for many other tasks, such as class-loading analysis, and we sometimes use JVM TI agents to profile and spot some differences in tests. And finally, I would like to mention how you can help us, dear users. Please don't hesitate to post issues on UTrack. All the performance-related issues are read. We check them all. We open all snapshots that you attach. We check all thread dumps that you attach, and we try to read and understand every performance degradation you have. So please don't hesitate. We have a special page on our support website how to report such performance problems to us, and where you can learn how to do this in more productive manner. And finally, I would like to say huge thank you to all the department, all the IntelliJ IDEA team, all the product teams for a lot of performance improvements last year. Without you, my dear colleagues, it would not be possible, and all the improvements done by many different teams and different people, I would like to say huge thank you again, and let's see how it goes further. We have a lot of plans for the next stages in here. Mala, I guess it is everything from my side. If we have some time for questions, we can cover a couple. If not, we can do this asynchronously.
First of all, thank you so much, Yuriy. That was a lot to cover in one session. So kudos to you. So we don't have a lot of time, just a minute. So I'll quickly take just a couple of one or two questions. So I asked how people for how long people have been using IntelliJ IDEA. So there were a lot of answers since for 2 years, since ever it has been around. So a lot of answers on that one. So one question that I have time to take is, so you talked about switching off the downloading in Gradle projects. So there was one question: how can we turn it back on? Automatic source downloading.
There is a such option in advanced settings, first of all, and also there is a huge button in Gradle tool window to do it once and for all. So for sure we have special toggles and switches. You can get it back easily. But from our usage data, we certainly know that really people do not use that for Maven a lot. Like not a lot of folks usually care about this. But if you care, you can switch it on and use it further for sure.
This is one question that I wanted to take. The simple reason was a lot of times developers think that some issue could be related to the performance of the IDE, but it might not be. So this issue could be related to something that the user is doing, or it could be IDE. So how do they make the distinction, and how do they navigate this problem? Similar problems.
Yeah, usually if you check our reporting performance problem page, you can easily spot that we ask you to hit some actions in IDE to collect some CPU snapshots and data, which exactly shows if it is related to IDE itself or not, because CPU snapshots, they easily show us.
That makes sense. And with that, thank you so much, Yuriy. That was an amazing session. Daniel was answering all the questions, amazing answers. So thank you so much again for your time, and we'll see you soon.
Yeah, thank you, Mala. See you.
Bye.
Bye-bye.